Now let us talk about second defect of vision, which is hypermetropia. Hypermetropia is also known as farsightedness. A person with hypermetropia can see distant object clearly but cannot see nearby object clearly. So students, how will you remember? Hypermetropia means farsightedness. Farsightedness means person can see far objects clearly but cannot see nearby objects clearly. So easy. When it was nearsightedness, that means a person can see nearby objects clearly. When it is farsightedness, a person can see far objects clearly. So simple, right? Now, let us again talk about near point. What is meant by near point? The minimum distance at which objects can be seen most clearly is called least distance of vision, or else it is called near point. Okay, so it is which distance? The minimum distance up to which the objects can be seen clearly. That is near point. We have already discussed about it in our previous session. So a person with this defect will have near point far away than the normal near point. We have already talked what is the normal near point for normal eye. It is about 25 centimeter. That is near point, right? So a person with this defect, with hypermetropia, will have this near point far than normal point, which means it will be far than 25 centimeter. Such a person has to keep a reading material much beyond 25 centimeter from the eye for comfortably reading. Let us see what happens with this defect. For hypermetropic eye, the light rays from a close-by objects are focused at a point behind the retina. As you can see, the figure which is for hypermetropic eye, the middle figure, there we can see that the light rays are focused behind the retina. Where they need to be focused? On the retina. Here, where do they focus? Behind the retina. And this defect arises because the focal length of the eye lens is too long, or the eyeball has become too small. It can be any of these two reasons. Either the eyeball has become too small or the focal length of the eye lens is too long. How can be this effect corrected? This defect can be corrected by using a convex lens of appropriate power. So, for correction of hypermetropia, we need to use a convex lens, because convex lens is converging lens. We have studied this in chapter number 10. Converging lens converge the light rays at one point after refraction. And what is the function of diverging lens? It diverges the light rays after refraction. Here it converges. So which is the converging lens? Convex lens is converging lens. So we will make use of convex lens of appropriate power for correction of hypermetropia. When we use convex lens, what happens? The light rays are first converged by the convex lens, so that after refraction they meet exactly at one point. Converging, they meet at one point. and so that the image will be formed on the retina. Okay, so this way we need to use convex lens for converging the light rays at one point. So this is all about hypermetropia, farsightedness. Now let us once again revise myopia and hypermetropia. For myopia, we learnt myopia is nearsightedness. We can say that for this defect, the image is formed in front of the retina. So, a person with this defect can see nearby objects clearly but cannot see distant objects clearly. And for correction of myopia, we make use of concave lens. Whereas hypermetropia is called farsightedness. For this defect, a person with hypermetropia can see distant objects clearly but cannot see nearby objects clearly. And what happens with the hypermetropic eye? The image is formed behind the retina. So, what is to be done? We will make use of a converging lens, which is convex lens. So, this is all about myopia and hypermetropia.